Good morning. Today we are going to take a new lesson in this video, which is the fifth lesson in calculus about applications on derivatives. Before we start, we have to revise some skills and some informations from the previous years that we will use it in this lesson frequently, like the equation of straight line. Let's start. First of all, the straight line, as we know, is an infinite set of points, and these points are order pairs formed from x and y, and this order pairs given by a relation between x and y, which is called equation of straight line. So any straight line, for example, if I have a straight line L, this straight line is formed from infinite number of points, and all these points are order pairs. These order pairs are given by a relation between x and y. For example, y equals x plus 1. This is a given relation. This is a relation between x and y, and this also generates order pairs. These order pairs will belong to this line. So we have to find the equation of this straight line now. To find the equation of this straight line, you should, given any point on this straight line, you should find it. Any given point, at least one point. For example, if I have a point here of coordinates x1 and y1, so to find the equation of this straight line, we will follow this simple form, which is y minus y1 equals m times x minus x1. And this is the simplest form to find the equation of a given straight line, where y1 and x1 are the coordinates of a given point, and m here means the slope of the straight line, and you should know how to find the slope. So let's start. For example, if I have a straight line, and I have a point on this straight line, for example 1 and 3, and the slope of this straight line is m here equals 7. So to find the equation of this straight line, the equation will be in the form y minus 3 equals m, which is 7, times x minus 1. So 3 is y1, 1 is x1, 7 is m. So let's simplify this form. 7 multiplied by x and 7 multiplied by -1. So it will be y minus 3 equals 7x minus 7. By simplifying this equation, the equation will be 7x minus y equals 4. And this is the equation of this straight line. As you see in this example, this is a relation between x and y, and it will generate all the order pairs on this straight line. This is the first point. The second one is to find the relation between any two straight lines. For example, if I have two straight lines, parallel straight lines, say if I have a straight line L1 and L2, are two straight lines. If two straight lines are parallel like this, these are two parallel straight lines, L1 and L2. If L1 is parallel to L2, if L1 parallel to L2, therefore M1 will be equals M2. And also, if L1 is perpendicular to L2, L1 perpendicular to L2, which means that the two straight lines are perpendicular, then we know that if L1 perpendicular to L2, this means to me that M1 equals -1 over M2, or in another form, M1 times M2 equal -1. That means that the slope of the first straight line will be the additive inverse of the reciprocal of the other slope. For example, if the first one, if M1, in this example, if M1 equal, for example, 5, M2 must equal -1/5. Reciprocal and change the sign. So these are the relation between two parallel lines and two perpendicular straight lines. Okay, and if the straight line is parallel to x-axis, as you know, if the straight line, here we have x and y-axis, if the straight line is parallel to x, the slope will be equal 0. And if the straight line is parallel to y-axis, this means that the slope is undefined. Undefined means a number over a over 0. Undefined. Awesome. Okay. Okay. Let's move to another part. Okay. Let's start the next part, which is as you know that the meaning of first derivative, the first derivative of a given function equals, or it's the same meaning of rate of change of this function, and also it's the same as slope of tangent to this function. And this is the I think it's the most important thing in this lesson, that the first derivative equals, or it's the same meaning of slope of tangent of the function given. Okay, and also it's the same meaning of tan theta, and also you have to know the meaning of theta. Theta here is the positive angle, which means that it must be anti-clockwise between the straight line and the positive direction of x-axis. This is the main definition of theta. And equals also dy by dx, or d by dx for f of x. All these meanings are equivalent to the first derivative. So when you find the first derivative of a given function, you also find the slope of the tangent of this given function, and also you find the tangent or tan theta of this straight line. Okay, for example, if I have a function f of x equals 5x power 2 plus 6x plus 7. When I find this this function is represented graphically by a curve, any given curve, I don't care. But this function, when I find the first derivative of this function, d by dx of f of x, it will be 2 times 5 equals 10, 10x plus 6. As you remember that when I want to find the first derivative of this polynomial function, this term, for example, I will multiply the power with 5, the coefficient, and subtract 1 from the power. It will be 10x power 1, then 6x. The first derivative of 6x is 6, and this number is constant, so its first derivative is 0. So the first derivative of the function is 10x plus 6. This means for me that the slope of the tangent of this curve, this function, is represented by a curve. The slope of the tangent, if I want to draw a tangent for this curve, the slope of tangent of this tangent is given by this relation at any point, at any value of x. For example, if this point is 1 and 5, so when I want to find the slope of the tangent at this point, I have to substitute x as equals 1. So slope here of tangent at x equals 1, it will be 10 times 1 plus 6, which equals 16. This is the value of the slope of the tangent at this point, as we already taken from previous lesson. Okay, let's start with the first example in the school book. Find the points which lie on the curve y equal x power 3 minus 4x plus 3, at which the tangent make a positive angle of measure 135 with the positive direction of x-axis. So this means that 135 is the angle theta. So here theta is equals 135. I don't know how can I use this given, but we should continue. And this is the equation of the curve. Y equals x power 3 minus 4x plus 3. First of all, what's the relation between the equation of the curve, the given curve, and the angle of the tangent, the angle which the tangent make? As we know that the first derivative of this function or this curve, the first derivative will give me the slope of the tangent, which is equal to tan theta. So the slope of tangent, I can find the slope of tangent from the relation tan theta. Tan theta here equals tan 135, which is equal -1. This is the slope of the tangent at the given the required point. So the slope of the tangent equals -1. Can I find the slope of the tangent by another method? Pause the video and think for 10 seconds and then complete the video. Actually, yes, we can find the slope of the tangent by another method. If I find the first derivative of this, the equation of this curve. So dy by dx equals 3x power 2 minus 4. This is the slope of the tangent at any point. So the slope of the tangent at any point will lead me to the slope of the tangent at the certain point here required. If the slope of the tangent at any point is 3x power 2 minus 4, and at the required point I need, the slope of the tangent will equal -1. So to find this point, I have to equalize that the value of the first derivative by -1. So it will be 3x power 2 minus 4 equals -1. By solving this equation, 3x power 2 equals 3. X power 2 equals 1. Therefore, x equals positive or -1. So, at the value 1 or -1, the slope of the tangent will make an angle 135 with positive direction of x-axis. Let's substitute by x in the curve to find the point. So here I have two values for x. So I will find two values for y. If x equals 1, so y will be equal 1 power 3 minus 4 times 1 plus 3, which is equal. I substitute by x in the equation. As you read from this question, find the point which lies on the curve. So when I substitute by x equals 1, I will substitute in the equation of the curve. Y equals 1 power 3 minus 4 plus 3, which is equal 0. And if x equals -1, y will be equal -1 power 3 between brackets minus 4 times -1 plus 3, which is equal to 7 minus 1 equals 6. So I have two order pairs now at not 1 and 0, and here at -1 and 6. So at these 2 points, the slope of the tangent will make an angle 135 with the positive direction of x-axis. Let's move to another example. Okay, in this example, find the slope of the normal on the curve of y equals tan by minus 2 over 3x at the point y and root 3. What's the meaning of normal on the curve? For example, if I have a curve like this, and this is the tangent to the curve at this point, this straight line is the normal to the curve. Normal which is perpendicular to the tangent. perpendicular to the tangent. So again, the normal means that it's perpendicular to the tangent. And as you remember that if the slope of the tangent is m, the slope of the normal will be -1 over m. Again, remember this skill when you solve or when you find anything about the normal of the curve. So find the slope of the normal on the curve. And this is the equation of the curve. When I find the first derivative of this curve, I will find the slope by finding the first derivative. I already get the slope of the tangent of this curve. Slope of the tangent, not the normal. So all we have to do is finding the first derivative, dy by dx, equals, as you know from the previous lesson, that tan, the first derivative of tan is sec power 2. So sec power 2 by minus 2 over 3x. This is the first derivative of tan. And the first derivative of the angle is by is a constant, so its derivative is 0. And negative over 3x, the derivative of this term is -2 over 3. So I will multiply sec power 2 by -2 over 3. So the first derivative is this value. And I need the slope of the tangent at the point by and root 3. So I will substitute x by. So dy by dx at x equals by equals to -2 over 3 sec power 2 by minus 2 over 3 by. This means that by minus 2 over 3 by is will be -2 over 3 sec power 2 by over 3. By over 3 means that it will be equivalent to 60 degree. So to find sec power 2 of 60 degree, you should write on the calculator, your calculator, 1 over cosine power 2, as you know that sec is the reciprocal of cosine. Cosine power 2, 60. It will be 4. So this is equals to -2 over 3 times 4 equals -8 over 3. This is the slope of the tangent. This is slope of tangent, not normal. To find the slope of normal, as you know that if the tangent is m, the normal is -1 over m. Find the reciprocal and change the sign. -8 over 3, the reciprocal is -3 over 8, and change the sign, it will be 3 over 8. Then next, to the next example. Example 3. Find the two equations of the tangent and the normal. So we need to find the equation of the tangent and the equation of the normal. The tangent to the curve and the normal to the tangent of the curve. And the equation of the curve is given, as you see, at the point lying on the curve whose abscissa is 2. And now we have a new term in our math language. What the meaning of abscissa? Abscissa is the x coordinate. Abscissa means x coordinate. So we have a point, we have a given point on the curve. This given point, its x coordinate is 2. But I don't know what's its y coordinate. And by the way, for your information, that y coordinate is called ordinate. So we have abscissa and ordinate. Abscissa is the x coordinate and ordinate is the y coordinate. So we need to find the ordinate or the y coordinate. To find the y coordinate in this point, we should substitute in the equation of the curve by x equals 2 to find y. So at x equals 2, y will be equal to times 2 power 3 minus 4 times 2 power 2 plus 3, which is equal 2 times 8 equals 16, 16 plus 3 equals 19, 19 minus 16, which is equal 3. So the equation, the point will be 2 and 3. This point belong to the curve and also belong to the tangent of the curve and also belong to the normal to the tangent of the curve. If I imagine that this is the curve and this is the tangent to the curve and this is the normal to the curve, all these lines or curves intersect at one point, which is 2 and 3. So this point belong to the tangent and also belong to the normal and belong to the curve. Now we need to find the equation of the tangent, and the equation of the normal. To find the equation of the tangent and the normal, we should, as you remember from the starting of the lesson, to find the equation of a given straight line, we should follow the formula, which is y minus y1 equals m times x minus x1. This formula, I need only one point on the straight line and also the slope of straight line. This for the tangent and also for the normal. To find the slope of the tangent, so I already have a point. 2, 3 is belong to the tangent and also belong to the normal. Now I need to find the slope of the tangent and the slope of the normal. To find the slope of the tangent, we have to find the first derivative of this function. So dy by dx will be equal 3 times 2 equals 6, and subtract 1 from the power. It will be 6x power 2 minus 4 times 2 equals 8, 8x power 1, and 3, the first derivative of 3 is a 0. To find, this is the slope of the tangent at any point. To find it at the certain point, which is 2 and 3, so at x equals 2, the slope will be 6 times 2 power 2 minus 8 times 2, which is equal 6 times 4 equals 24 minus 16 equals 8. So the slope of the tangent is 8. So slope of tangent equals 8, and slope of normal, as you know and as we say, will be negative 1 over 8. So here we have the slope of the tangent and the slope of the normal, and both of the two straight lines have the same point on them, 2 and 3. So equation, to find the equation of tangent, it will be y minus y1, which is 3, equals m, which is 8, times x minus x1, x minus x1, which is 2. And by simplifying, you will find the equation of the tangent, and it will be y minus 8x equals negative equals negative 13. This is the equation of the tangent. Equation of normal, it will be y minus y1, which is 3, equals negative 1 over 8 times x minus x1, which is 2. By simplifying this equation, the equation of the normal will be 8 y plus x minus 26 equals 0. Let's move to another example. Okay, in this example, find the equation of the tangent to the curve y equal 4x minus 10x. Y equal 4x minus 10x. At the point y over 4 and f by over 4. f of pi over 4. Here this point is not completed, so we have to find the value of f of pi over 4. F of pi over 4 means in the equation, or the equation of the curve given, we have to replace x by pi over 4 to find the image of x. So first of all, we have to find f of pi over 4, which is equal to 4 times, instead of x, we will put pi over 4 minus 10 pi over 4. And this is 4 will be cancelled with 4, and it will be pi minus 10 pi over 4. Pi over 4 here equals 45. So 10 45 equals 1. So it will be pi minus 1. So the point is pi over 4 and pi minus 1. And remember, this point belongs to the curve and also belong to the tangent, because it's the point of tangency, the curve and the tangent, and this is the point of tangency, which is pi over 4 and pi minus 1. And here we need to find the equation of the tangent to the curve, the given curve. So to find the equation of the tangent, we should first find the slope of the tangent. Slope of tangent. Slope of tangent, we can find it, which is m, by finding dy by dx. dy by dx equals, for x, the first derivative of 4x will be 4, minus 10x, it will be sec power 2x. And I need to find the slope at the point pi over 4. So m at the point pi over 4 and pi minus 1 equals, I will replace x by pi over 4, so it will be 4 minus sec power 2 pi over 4, which is equal to 2. And as you know, that sec power 2 is 1 over cosine power 2. So you can find it by writing on the calculator 4 minus 1 over cosine power 2 pi over 4, or 45, to find the value of the slope. So here we have the slope, and also we have a given point and the slope. By substituting in the formula of the equation of straight line, it will be y minus y1, which is pi minus 1, equals slope, which is 2 times x minus x1, which is pi over 4. By multiplying 2 in both terms, it will be y minus pi plus 1 equals 2x minus pi over 2. And after simplifying the equation will be y equals 2x plus pi over 2 minus 1. And here's the equation of the tangent to the curve at the given point. Let's move to another example. Okay, in this example, if the curve y equal ax power 3 plus bx power 2, and here's the equation of the curve is not complete, because there is more two parameters or two unknowns, a and b, in the equation of the curve. Touch the straight line y equal 8x plus 5. This is the equation of the tangent. So in this example, the equation of the curve is given, but with two unknowns, a and b, and the equation of the tangent also is given, and the point of tangency also is given. So we have a tangent, a curve and a tangent, and the point of tangent. The equation of the tangent, the curve is y equal ax power 3 plus bx power 2. The equation of the curve is the tangent equal y equal 8x plus 5, and the point of tangency is -1 and -3. And remember that this point, the point of tangency, belong to the curve and also belong to the equation of the curve and also belong to the equation of the tangent. So I can substitute by x and y here and here by the given point. Okay, let's start to find the value of a and b. First, I can substitute directly by the point and the equation of the tangent. So at the point -1 and -3, the equation of the tangent, the curve will be -3 equals a times -1 power 3 plus b times -3 power -1 power 2. So it will be -3 equals -a plus b, which means in the simplest form b minus a, or we can write it in more ordered method: a minus b, a with positive sign, b with negative sign, and -3 with positive sign. It will be a minus b equals 3. And here we have an equation between two unknowns, a and b. So as we know from previous years, that if I have two unknowns, I should have two equations. So I have to search for another equation to find another relation between a and b. So the relation, I can find the relation from the first derivative of this curve, dy by dx, dy by dx equals 3ax plus 2bx. And this is the slope of the tangent at any point, but I need the slope of the tangent at a certain point, which is -1 and 3. So at x equals -1, the slope will be, by substituting by x as -1, the slope will be -3a minus 2b, sorry, -3ax power 2, sorry, 3ax power 2 plus 2bx. This is the first derivative of the equation of the curve. By substituting instead of x by -1, it will be طيب stop.